online e-learning platform, that is Gradeup, my friends. So today we will discuss about the matrix method, my friends. And if you don't know the basic concept, my friends, I will tell you the basic concept of matrix method also, so that you are able to solve the problem. Okay, so let me know, my friends, I'm perfectly audible as well as visible to all of you or not. Quickly just respond in the comment box, my friends. And just share this particular video so that everyone can join this particular session, my friends, and definitely they will get the benefit from this session. Okay, my friends, so let me introduce myself. My name is Krishna Yadav, and I had 8-year teaching experience in this particular field, my friends. And I done my masters from IIT Roorkee. I mentored almost 14,000 plus students for these examinations, and my area of expertise are these, right? So no, good evening, hello. Suvir, yes sir, good evening, good evening. Anusha, good evening. Okay, Akshan, good evening. Come fast, my friends, come fast. So, my friends, this is the first question in front of you with respect to your stiffness matrix. Now, let me tell you the basic concept of stiffness matrix first, then we will take the problem over here. Okay, so my friends, you know that there are two type of matrix method. One is your stiffness matrix method, and another is your flexibility matrix method. One is force method, another is your displacement method or stiffness method, right? In which the unknowns are displacement. In our force method, unknowns are redundant reactions. Okay, so in case of stiffness matrix method, my friends, the unknowns are joint displacement. And how to calculate the total number of unknown joint displacement? Just you have to find the value of dk. Just you have to find. क्लियरिटी नहीं है सर. Are you not able to see the font? Tell me. Tell me guys, are you able to see the font or not? All of you. You are able to see now? Okay. So let's understand, my friends. Let's understand the concept. Okay. So my friends, whenever we are using the stiffness matrix, so what are the unknowns? That is your dk. That is our dk value, right? The unknowns are dk over here, which is kinematic indeterminacy. And generally, we consider member as inextensible. Listen carefully. Member as inextensible. Inextensible. Okay, guys? Okay, sir. Sonu says, sir, A hoga. Okay, okay. So let us suppose this is the one structure, my friends, in front of you. Let us suppose this one is the structure, which is a cantilever beam. Now you know that, my friends, if we consider this particular member as an inextensible, so only two joint displacement are possible, right? Where it is so, my friends, one, it will move in the downward direction, and another is your rotation, right? So can I say that, my friends, this is your theta 1 as a rotation, and this is your delta 2, which is acting downward. Now tell me guys, if we want to develop the jth column of stiffness matrix, how we can develop it? Listen carefully. As per this condition, you know that, my friends, there are two unknowns over here. So we can say that dk value is equal to how much, sir? It is 2. Dk, it is 2. Dk is equal to 2. Okay. So what will be the order of stiffness matrix? It depends upon what? Total number of kinematic indeterminacy. So can I write it, my friends? K2 cross 2 is equal to how much? Sir, the element are K11, K12, K21 and K22. Now how we can find these elements, my friends? So just see this particular column first. Just see this particular column first. This one. Just see this particular column first, right? This one, my friends, in which you are able to see this one, my friends. One is common over here. 1 is common over here, right? So what we have to do, we have to give unit displacement in the direction 1 only. Listen carefully. In this particular column, what we have to do, 1 is common in both the element, right? So what we have to say, my friends, you have to give unit displacement in direction 1 only and restrain other given coordinate direction and find the force developed in direction 1 and direction 2. So you will get two elements, K11 and K21, right? So my dear friends, these element is to be represented in this manner, which is Kij, right? So what we are doing, my dear friends, we are giving unit displacement. Listen carefully. Unit displacement in direction J, in direction J, and find forces in all given coordinate direction, or we can write it and find force in direction I. It is very simple, right? Now my dear friends, you are able to understand, right? Now tell me what will be the answer of this question. To generate the jth column of stiffness matrix, what we have to do? Listen carefully. We are giving unit displacement in direction J. Yes, sir. So unit displacement in direction J and forces in all the coordinate direction are calculated. Now tell me guys, what will be the correct answer? A is the correct answer. Tell me, understood? Clear sabhi ko? A is the correct answer, my dear friends, right? What we have to do, just give you unit displacement in direction J and find forces in all the given coordinate direction. So A is the correct answer over here. Okay, later on we will understand how to develop these type of values in a given structure in the later question. Okay, so let's move to the next question, my dear friends. Let's move to the next question. This is a MSQ type problem. This is a MSQ type problem, my dear friends. So first you have to understand, my dear friends, some important property. If you understand these property, then you are able to solve the matrix method problem in ESC examination by using directly the properties, my dear friends, and without writing anything, you can eliminate the option also. But first you have to understand what are the basic properties over here for stiffness matrix as well as flexibility matrix. There are three properties, my dear friends, which we have to understand. Okay, so first property is whether it is stiffness matrix, or flexibility matrix. In both the matrix, these property are to be valid, my dear friends, right? So stiffness matrix ho ya flexibility matrix ho, first property says, my dear friends, it is always a square matrix. It is always a square matrix. Okay sir, ये क्या होगा सर? हमेशा square matrix होगा. It is always a square matrix. If it is square matrix, what will be the order of matrix? It is always n cross n. It is always n cross n, right? So it means if you are writing K matrix, so you have to write 2 cross 2. If you are writing flexibility matrix, so you have to write 2 cross 2 or 3 cross 3 and so on, right? These combination are possible, but if you write 2 cross 3, 3 cross 1, then it is not possible, my dear friends, right? You can eliminate these type of options. Okay, second one, my dear friends, second important property. Now you know that, my dear friends, if we want to represent the matrix over here like this one, let us suppose K 3 cross 3, right? So it means there are three coordinate direction. I will tell you, my dear friends, how to decide the coordinate direction also in case of flexibility matrix as well as stiffness matrix. I will tell you. Okay, so this one is K11, K12, K13, K21, K22, K23, K31, 32 and 33, guys, right? These are the element. Total 9 elements are there. This particular column or this particular elements, my dear friends, is known as column 1 elements. These elements, column 2 elements. These elements, column 3 elements. Okay, now listen carefully. Now these elements are diagonal elements. Listen carefully, my friends, it is very, very important. These elements are diagonal elements, and these diagonal elements are always, always positive, and it is non-zero. Listen carefully. Diagonal elements, diagonal elements are always positive. It is always positive, my dear friends, right? As well as non-zero. It has some magnitude. Non-zero. Okay, sir. Now, diagonally opposite element. What are the diagonally opposite element? These are the diagonally opposite element. These are diagonally opposite element. These are diagonally opposite element. So, my dear friends, the third property says diagonally opposite element, diagonally opposite element, opposite element are always, always same. Why it is so, my friends? Because of Maxwell reciprocal theorem. Maxwell reciprocal theorem. Because of Maxwell reciprocal theorem, guys, right? Due to which these diagonally opposite element are always same, like k12 is equal to k21, right? K13 is equal to k31, and k32 is equal to k23. Okay, guys, now tell me the answer of this one. Okay, so consider the following statements relating to the structure analysis. The first statement says, listen carefully, the first statement says flexibility matrix and its transpose are always equal, right? So this statement is correct or wrong? Let's understand, my friends. What do you mean by transpose? You know that. Let's suppose if we write a flexibility matrix whose order is 2 cross 2. What are the element? F11, F12, F21 and F22. So this is our flexibility matrix. If you take the transpose, so what you have to do? You have to just interchange row with column, right? So my dear friends, if we take the transpose of this particular matrix, so what we will get? We will get over here F11 and F12 and F21 and F22. Now tell me, guys, as per our property, these two elements which are diagonally opposite element are always same in nature. Same in nature as well as same in magnitude. So tell me, guys, if you interchange these two elements, if you take the transpose of this particular matrix, then you will get the same matrix or not? Yes, sir, we will get the same matrix. So first statement is correct. First statement is correct. Yes, sir. What is the second statement? Elements of main diagonal of stiffness matrix are always positive. Yes, it is also correct. मैंने अभी आपको बताया, right? For unstable structure, listen carefully. For unstable structure, coefficient in leading diagonal matrix can be negative. My dear friends, if you use any unstable structure, so you are not able to apply the method of structure analysis, because these method of structure analysis are only applicable on your stable structures. Understood? Whether it is determinate, whether it is indeterminate, that is the concept which we have to use later on. Okay, but the first thing, we have to eliminate unstable structure first. So answer, this one, this one, this one is wrong, right? Now the last one is, my friends, stiffness matrix method is only applicable to indeterminate structure. Again, this one is wrong. Haha. Let me tell you why it is so, because this is a very good question. Let me tell you, my friends, why it is so. Listen carefully. Listen, whenever in your structure analysis, if they give the question like this particular structure is determinate, indeterminate, so my friends, the basic or the general indeterminacy is based on your static one. So it means they are saying that stiffness matrix method is only applicable to statically indeterminate structure. No, my dear friends, it is also applicable on statically determinate structure. How it is possible? Let me tell you, let me show you. Listen carefully. My dear friends, let's suppose if we have two structure over here like this one. This is a simply supported beam which is statically determinate. You know that ds value is equal to how much? 0. But if we talk about dk value, my friends, what is the value of dk over here? Can I write it, my friends? It is 2 if we consider member as a axially rigid. Okay, so this one is theta 1, this one is theta 2, and let us suppose if you take the axial deformation also, so you have to put delta 3 over here, right? So my dear friends, if you neglect that, so you have to take 0. If you consider it, delta 3 is to be considered. Okay, sir. So my dear friends, in this particular case, theta 1 and theta 2 are variable when we are considering member as axially rigid. Okay, sir. Now tell me guys, what is the value of dk over here? It is 2. So can I say that it is statically indeterminate or determinate? Determinate, and kinematically indeterminate. Now my dear friends, if this particular structure is kinematically indeterminate, then you are able to apply the stiffness matrix method over here. Because stiffness matrix method says it is a displacement method. If any structure have some unknown displacement, then you are able to apply that particular method to find out the value of unknown joint displacements. Understood? This is the concept. So my dear friends, we can say that in this particular structure, stiffness matrix method is to be applicable. Let me show you one more thing. Let's suppose this one is fixed, this one is roller, this one is roller, and this one is fixed. Okay guys, now my dear friends, let us calculate the value of ds first. Again, we are considering the member as axially rigid. So how many reactions are there? 3, 4, 5, 6, 7, 8. Now my dear friends, if you calculate ds value, so it is equal to 3 plus 3 and 2, 8 minus 3, it is 5. Okay sir. And what about dsi? If we take dsi, it is 0. Why it is so? Because it is an open structure. Now in this case, ds is equal to 5. If you calculate the value of dk, you know that my dear friends, only 2 rotation are there, theta 1 and theta 2 guys, right? So dk value is equal to how much? 2. Now this particular structure is statically indeterminate structure. This one is statically determinate structure, but in both the structure you are able to find out the value of theta 1, theta 2, theta 1, theta 2 by using stiffness matrix method. Understood? It is a very, very important point. So just remember this point, my dear friends. Stiffness matrix method can be applicable to determinate as well as indeterminate structure both. So D is the wrong answer. Only A and B are correct. A correct है, B correct है, right? Okay guys, okay guys. Now let's move to the next question and tell me the answer of this one. Tell me the answer of this one. What will be the size of stiffness matrix for structure shown below with degree of freedom? Now, let me tell you, my dear friends, how to decide the coordinate direction. Listen carefully. How to decide the coordinate direction and how to decide the order of matrix also. So let me tell you, my dear friends. First, in case of stiffness matrix, we have to find the value of dk. We have to find the value of dk. Let us suppose in this particular structure, all the members, listen carefully, all the members are axially rigid, right? So only 3 joint displacement is possible, which is theta 1, theta 2 and theta 3. So can I say that, my dear friends, in this dk is equal to how much, sir? Dk is equal to 3. And whatever your kinematic indeterminacy is there, my dear friends, this is the order of stiffness matrix. And it also shows that, my dear friends, it also shows the number of coordinate direction which is to be present on our principal structure. This is nothing as this is your principal structure on which we are writing the unknown joint displacement like theta 1, theta 2 and theta 3. Okay, so my dear friends, the order of matrix is depend upon what? dk. In case of flexibility matrix, it depend upon what? ds, right? So the order of matrix is equal to how much? 3 cross 3. So how many elements you will get? 9 elements you will get, my dear friends. Okay, so the order will be A. A is the correct answer. A is the correct answer. Understood? Okay, sir. Now this is the question, my dear friends. This is the question. Flexibility matrix. Flexibility matrix. Okay, sir. Now what we have to do, my dear friends, to find out the flexibility matrix over here. Listen carefully, my dear friends. Just remember these property first. Just remember these property first. Square matrix, diagonal element always positive, non-zero. Diagonally opposite element are always same in magnitude as well as same in sign. It means both the element have same nature as well as same magnitude. Okay, sir. Now let's apply these three property first in the options. Okay, so that we are able to eliminate some of the option. Okay, let's check it, guys, whether we are able to eliminate something or not. Okay, so in this particular option, no, we can not eliminate this one. We can eliminate this one, my friends. Why it is so? Because you are able to see here, I'm just trying to put the question and trying to solve the question in a shortest duration, my friends. Now you can see here, one of the diagonal element is negative, so you can eliminate this one. This is the wrong one, right? Now this one, it may be possible, this one it may be possible, and this one, my friends, it is not possible. Why it is so? Because you can see here, these diagonally opposite element are different, so definitely this will not the answer. Okay, sir. Now my friends, I can put the answer directly over here just by seeing the diagram now, right? How it is so? Listen carefully. Listen carefully. Listen carefully. This is your structure. Without solving the problem, you can solve the problem also, my friends. And this is nothing as this is the tricks, right? Listen carefully. Let's suppose this is our load, which is one coordinate direction, and this is second coordinate direction, and EI is given to us, and this is 4 meters span. Okay, sir. Now these are the coordinate direction, and whatever coordinate direction are there, these are the order of matrix. So flexibility matrix, it is 2 cross 2, and the elements are F11, F12, F21 and F22. Let me tell you, my friends, the basic concept how to solve this particular problem directly, but just thoda sa ek cheez dekhni hai, right? We have to see one thing only over here. My friends, when these element will be negative over here, listen carefully, listen carefully, listen carefully, then only you are able to eliminate this particular option. Okay, when these element will be negative over here, let's understand. You can see here, my friends, these are column 1 element and these are column 2 element, right? Column 1 and this one is column 2. So my friends, in case of flexibility matrix, these element will represent what? We have to understand it. So what is the common parameter over here? It is 1, 1, 1, 1. 1 is common over here. So what we have to do? Give unit force, listen carefully, give unit force. Unit force means it may be linear force, it may be angular force. It depends upon the direction of coordinate. Like this one is linear, so you have to apply linear force. This one is angular, you have to apply the angular force. Give unit force in direction 1 only and measure the displacement in direction 1 and direction 2. Okay. Sorry, my friends. So let me show you, my friends. Let me show you. This is the direction 1. What we have to do? We have to apply the unit force over here. F is equal to 1. So what will happen, my friends? It will try to deflect in this direction. Yes, sir. Now, my friends, what we have to do? We have to find the displacement in direction 1 and direction 2. Listen carefully. Listen carefully. Then only you are able to understand it. Okay. Then we will eliminate the option number A. Okay. So, my friends, this particular displacement, just see this one. My friends, tell me, if you apply the force in downward direction, then definitely this particular joint will move in downward direction, right? So this one is what? This one is our F11 element. And what is the direction of rotation of this particular joint? It is in clockwise direction. So this is nothing as this is your F21 element. It means you are applying unit force in direction 1 and measuring the displacement in direction 2. So tell me, guys, if the direction of this particular F21 is same as the direction of coordinate 2, then your F21 is always positive. Is always positive. Understood? So my friends, this particular option is not possible because it is negative over here, right? So we can eliminate this one also. Let us suppose if this particular direction will become anti-clockwise. So my friends, you have to eliminate this one because it is positive over here. And why we are eliminating? If this particular direction is anti-clockwise and our direction of coordinate 2 is clockwise, then definitely this particular element should be negative over here, right? Understood? So this is the basic trick how to eliminate the option in matrix method. Now, if you want to solve the problem, we can solve it, my friends, no problem. Let's solve it and understand how to calculate these values also. Okay, this is a basic idea. Okay, so let me tell you, my friends, what is the value of f11? So it is very simple. F11, can we write it? It is fl cube by 3i, and it is always positive because the direction of f11 is downward as well as our coordinate direction is downward. So what is the value of f? It is 1. What is the value of L? It is 4. 4 cube 64. So plus 64 divided by 3i. Next, F21. F21. What is the value of F21, sir? We have to apply unit force in direction 1, measure the displacement in direction 2, and it is equal to how much? You know that, my friends. What will be the theta when a load, a point load is to be applied at the free end? It is equal to FL square by 2EI. Right? What is the value of F? Sir, 1. What is the value of L? It is 4. 4 square 16 divided by 2, 8, and it is positive. Why it is positive? You know that, my friends, because the direction is clockwise as well as this one is also clockwise. Right? So definitely F21 is 8EI, 8 by EI. Okay, sir. So what about other two elements? What about other two elements like this one? इनका क्या हुआ सर? So my friends, what we have to do? We have to apply the unit force in direction 2. But in direction 2, my friends, you can see here it is your movement, right? So we have to apply unit movement over here. Okay, guys. So let us apply unit movement first. Unit movement. For column 2, you have to apply unit movement. So let's apply unit moment over here, which is m is equal to 1, guys. So what will happen? It will try to deflect in this manner and you will get a theta over here, right? As well as this delta, as well as this delta. Okay, sir. Now, just see this one, my friends. Just see this one. This particular element, this one. What it represent? It represent F12 because we are applying unit movement in direction 1 and measuring the force in direction 1. Sorry, we are applying the unit movement in direction 2 and we are measuring the unit displacement in direction 1. We are measuring the displacement in direction 1. And this theta is equal to what? Sir, it is F22, right? Okay, sir. So what is the value of F12? Sir, it is very simple. It is also equal to F21, or we can write it. It is ML square by 2EI. What is the value of M? It is 1. What is the value of L? 4 square divided by 8EI. Just solve it, guys. What you will get? What you will get? 8 by EI. Okay, sir. What is the value of F22? It is very simple. Sir, F22 is equal to ML by EI. So what is the value of M? 1. L 4 EI. So 4 by EI, guys. Right? So this is the concept. By using this particular method, you are able to solve this problem. But my dear friends, this is not the smart work. This is the laborious work, right? You are taking a lot of time to find out these elements, right? To find out these elements, you are taking a lot of time. But by using the concept of matrix method, you are able to solve the problem in the quickest manner. Like C is the correct answer over here. You know that how to solve it. Yes, trick is like that. निगाहों से उड़ाना है. Definitely, my friends, this is the trick which is known as निगाहों से उड़ा दिया, right? Okay, let's move to the next one. My dear friends, one more property you have to understand. Always remember this thing. Whenever you have a flexibility matrix, it is always inverse of stiffness matrix. Or whenever you have a whenever you have a stiffness matrix, my dear friends, so you have to take the inverse of what? Flexibility matrix, because both are inversely proportional to each other, because both are inversely proportional to each other. I don't know why it is, why, what is happening in my neck. Okay, no problem guys, let's understand. Flexibility matrix for a beam element is written in the form of what? So my friends, this is our flexibility matrix. What we have to do, we have to find the stiffness matrix over here. We have to find the stiffness matrix over here. How we can find it? Just we have to take the what? Inverse of it. Just take the inverse of it, you will get the answer. Now tell me guys, what will be the answer? All of you. Option C might be wrong because 6 by EI. So once check F22. This one guys, wait a second. Yes. Wait a second. Okay. It should be ml by ei, and what is the value of m? It is 1. L is equal to 4 and divided by ei. 4 by ei. Yes, it should be like this one. It should be 4 by ei, right? You are correct. It should be 4 by ei, right? Now it is okay. Now it is okay, I think so, right? I think there is some typing error over here, right? It is typing error over here. No problem, my friends. It is 4 by ei. It is 4 by ei, right? But we solve this problem, my friends, also in this manner. But you are able to understand the trick, my friends. What is the trick behind these concept? But you have to remember the property first. Then only you are able to solve this one. Okay, sure, bhai. So let's move to the next question. Okay, guys. So what is the corresponding stiffness matrix to this flexibility matrix first? Okay, so tell me guys, what will be the answer? What will be the answer of this question? What we have to do, my friends, if you want to take the inverse of this particular one, which is nothing as our flexibility matrix. Okay, so my friends, what we have to do, we have to find the adjoint of f divided by mod of f. Okay, adjoint of f and divide by mod f. Now what is the value of mod f, my friends? So let me write here, my friends. Mod of f is equal to L cube by 6 ei bracket 16 into 2 minus 5 into 5, right? Just solve it, guys. So how much it is? 16 into 2 minus 5 into 5. So we are getting a value of 7 L cube by 6 ei. Okay, sir. This is the mod of f. Now, my dear friends, only two options are there in which mod of f is to be written like in this manner, right? It is the inverse of mod of f, nothing as 6 ei by 7 L cube. So my dear friends, these options can be eliminated. Okay, sir. Now, excuse me. Now, which option is the correct answer over here? Now tell me, guys. D or B? D or B? What we have to do? We have to find the adjoint of f also. Adjoint of f. So how to find the adjoint of f? It is very easy. It is 2 cross 2 matrix here, right? You have learned the concept of adjoint of f or adjoint of any matrix, how to find it in the mathematics. What we have to do, my friends, we have to interchange these two elements. I'm just trying to use the direct concept. Just interchange these two elements and change the sign of diagonal element. Okay, so it means you have to write 16 and 2 over here, and it is minus 5 and minus 5 like this one. So D is the correct answer. D is the correct answer. Listen carefully. How to find the inverse of 2 cross 2 matrix? What you have to do? Just find the mod. After that, just interchange these element and change the sign of diagonal element. Nothing else. Okay, this is the adjoint. Just divided by mod of f. So it means 7L cube by 6EI. Write it, my dear friends. 6EI by 7L cube, and just take the mod over here. Okay, which option is correct? B कौन बोल रहा है भाई? Shakina, it is D. It is D. It is D. D is the correct answer. D is the correct answer. Okay. Now this is the next question, my dear friends. This is the next question in which we have to find the stiffness matrix. Now let's understand, my dear friends. Again, this is a very, very good question, and we have to consider only flexure deformation over here. Flexure deformation over here. Flexure deformation, right? Only flexure deformation we have to consider, right? Do not consider any sway deformation over here, right? Only flexure deformation. Now, my dear friends, which is the stiffness matrix for the plane frame shown in the figure given below, right? We have to find it. So my dear friends, this is the figure, which is nothing as a frame over there, and there are two directions, which is direction 1. This one is direction 1, and this one is direction 2, which is in this direction, and this is in this direction. Okay, sir. So just try to draw the principal structure of this particular given structure. Okay, so let me draw it, my dear friends. It is to be like this. While drawing the principal diagram, my dear friends, of principal structure, what you have to do? You have to remove the external loading. Whatever loading is to be given, just remove it and try to apply the coordinate direction only. Direction 1, and this is direction 2. And write all the parameter, which is your geometrical property over here. 3EI, EI and EI, as well as length, which is 6 meter. And this one is 4 meter. Okay, sir. Now, my dear friends, what we have to do? We have to find the stiffness matrix. Now, how many coordinate direction is given to us? 1 and 2. So it means the order of matrix is 2 cross 2. Sir, it is 2 cross 2. How many elements? 4 elements are to be there. It means K11, K12, K21 and K22. Okay, sir. 4 element is to be given to us. Okay, sir. Now, my dear friends, now, what we have to do over here? Listen carefully. For first column, listen carefully, my dear friends. To develop the first column, this is the first column elements, and these are the column 2 elements. To find out the column 1 element, my dear friends, what we have to do? You can see here, in these 2 element, which term is common? It is 1. So we have to apply the unit rotation in the direction 1 only. Apply unit rotation in direction 1 only, and restrain other given coordinate direction. What is other given coordinate direction? It is 2. So we have to restrain it. It means we have to fix it. Okay. And find the forces developed in direction 1 and direction 2. It means it is K11 and K21. Okay. So just do it, my dear friends, and solve it. Can I write it? Sir, column 1 elements. Column 1 elements. Okay, sir. What is column 1 element over here? Apply unit rotation in direction 1 and restrain direction 2. So, my dear friends, you have to fix the direction 2 first. Okay, this is fixed. And there is one more member over here, but it is not useful for this particular analysis, but we have to draw it. Now, apply the unit rotation over here. Theta is equal to 1. So what will happen, my dear friends? This particular joint will try to rotate in clockwise direction in this way, right? And it will deflect in this manner. Will deflect in this manner. Okay, sir. Now, my dear friends, how much movement is to be required to rotate this particular joint? Can anybody tell me, my dear friends? You know that it is nothing as summation of K. So this is equal to 3EI. The flexure rigidity is given to us 3EI, and it is EI over here. And what is the length over here? It is 6 meter, and I think this is 4 meter. Okay, guys. Now, my dear friends, if you want to find the K11 element, what is the value of K11? Sir, it is nothing as summation K. summation k at this particular point, right? Because this is the one direction, this is the direction one only, right? So can I write it, my dear friends? For this particular member, 4 ei by L, this member 4 ei by L. So let's put all the values over here. 4. What is the value of ei? 3 ei divided by L. L is equal to 6 meter. Okay, plus 4 into ei divided by 4. Okay, just solve it, guys, and tell me the answer. 4 into 3 divided by 6 plus 1. Okay, we are getting a value of 3 ei over here, right? This is k11. Now, what is the value of, listen carefully, what is the value of k21? What is the value of k21? How we can solve it? So my dear friends, we have to use the moment distribution concept over here. Then only we are able to find this one. But let it be, my dear friends. Let's solve another one. Let's solve another one. Then we will come back to this one also. Okay. So let me solve this one. We will solve it. No problem, my dear friends. We will solve it. But let me show you something. Column 2 element. Column 2 element. So my dear friends, for column 2 element, what we have to do? Again, we have to fix direction 1 and we have to apply unit rotation in direction 2 only. It means theta is equal to 1. Then this particular portion will try to deflect in this manner. Okay, sir. It will try to deflect in this manner. Okay, sir. Now, my dear friends, again, the same parameter is to given us, that is 3 ei and 6 and ei and 4. Okay, sir. Now, this particular element is nothing as k22, right? And this k22 is nothing as summation k. So, how much summation k is there, my dear friends? Can I say that again, you have to apply same amount of movement over here? Yes, definitely. So, can I write it? It is 4 into 3 ei by 6 plus 4 into ei by 4. Okay, just solve it. You will get the same value, which is 3 ei. Okay, sir. So it means, listen carefully, my friends. It means you are getting k11 and k22. These are diagonal elements, and diagonal elements is 3 ei and 3 ei. Just check it, guys. B is the correct answer. Just check it. B is the correct answer. Without solving diagonally opposite element, we are getting the answer, my dear friends. Because this is the objective problem, we have to use the shortest manner to get the correct answer. Tell me, guys, are you able to understand? Option B, definitely option B is the correct answer, right? But if you want to solve this particular problem, my dear friends, if you want to solve this particular problem completely, then listen here. Listen. You know that, my dear friends, at this particular joint, how much moment is there? It is 3 ei. Now let us suppose this is the stiffness, this one is 2 ei and this one is ei. Okay, sir. So my dear friends, listen carefully. You know that at this particular joint, this is our joint. Listen carefully. This is our joint. What we have to do, we have to just find the moment over here. Listen carefully, which is k21, right? Now at this particular joint, a moment is to be applied, which is equal to 3 ei. And what is the stiffness of this member? What is the stiffness of this member? It is 2 ei. It is 2 ei. And what is the stiffness of this one? It is ei. So my dear friends, it will take a moment of 2 ei over here and it will take a moment of ei over here. So similarly, my dear friends, it is 2 ei. Now my dear friends, if you apply a 2 ei moment over here, what is the carryover moment at the far end? It is half of that, which is equal to ei. So definitely the k21 is equal to ei. It means 1. And similarly, we can say that diagonally opposite element are always same. So k21 and k12 is equal to how much? Sir, it is ei. PR के एग्जाम में इतना भी टाइम मिलेगा, मुश्किल हो जाता है जब प्रॉब्लम नहीं होते हैं. थैंक यू सर फॉर दीज ट्रिक्स. थैंक यू सो मच स्वामीजी. थैंक यू सो मच फॉर योर compliment. Definitely, my dear friends, definitely you are not able to solve all these things, but you have to focus over the concept and over the tricks, right? Then you are able to eliminate the option as well as you will get the correct answer, right? Okay guys, okay guys, so this is the next problem. This is the next problem, my friends, in front of you. So the stiffness coefficient, which is K11 for the beam as shown below is. So what we have to do, we have to just find the K11, which is nothing as, my friends, this is the only direction which is given to us, that is your direction 1, and we have to find the K11 element over here. So what we have to do, as per K11, you have to give unit force in direction 1, unit displacement in direction 1, and find the force in direction 1 only. Okay, so let me write here. What do you mean by K11? Unit force, unit displacement in direction 1, unit displacement in direction 1, and find force develop in direction 1. Okay guys, it is very simple. So let's do it. It is very easy. So listen carefully. Let us suppose this is your fixed beam. Okay, and we are giving a unit displacement in direction 1. So what will happen, my friends? This particular beam will try to deflect in this manner, because there is one hinge over here. There is one hinge over here, right? So my friends, this is our unit displacement, which is delta is equal to 1. Listen carefully. This is our unit displacement, which is delta is equal to 1. Now definitely there is some force by which this particular displacement will occur, right? So let us consider that is your F. Okay, so this distance is A, this distance is B. So my friends, we have to find the value of this F force. So let us separate this particular member. Okay, let's separate this particular portion, which is this one, my friends. This is your A distance, and it is trying to deflect in this manner. Okay sir, now my friends, let us suppose this is your force F1, and you know that, my friends, delta is equal to how much? 1, and this particular point is what? Hinge. So you know that, my friends, whenever free end will try to deflect by delta, so the moment will develop at this particular end, it is equal to how much? Sir, 3ei delta by L square. What is the value of L? It is A, so A square over here, right? In similar manner, my friends, in similar manner, the other part is to be like this. Here it is F2 force, sir. You know that F1 plus F2 is equal to how much? Sir, it is 1. Okay, sir. So, my friends, it will try to deflect in this manner. Slope is 0 over here, right? And this is our delta, and again delta is equal to 1. So, my friends, this particular moment is nothing as, it is 3ei delta by B square, and this particular distance is equal to how much? B, sir. Okay sir, now let's solve this one, my friends. Let's solve this one. So let us take this part as first and this part as 2. Now just calculate the value of force F1. So can I write it, my friends? This particular point is A, this particular point is B. So can I write it? Summation moment at A is equal to how much? So it is 0. So can I write it? F1 into A minus 3ei delta by A square is equal to 0. So can I write it, my friends? F1 is equal to how much? 3ei delta by A cube. And what is the value of delta? It is 1. So similarly, my friends, if you solve the second part, what you will get? Again, you will get F2 is equal to how much? Sir, it is 3ei delta by B cube, and delta is equal to how much? Sir, 1. So my friends, just you have to add both of them. So can I write it? F is equal to F1 plus F2, and it is equal to 3ei bracket 1 by A cube plus 1 by B cube. And this is the force required. To give unit displacement at this particular joint. So what will be the answer? C is the correct answer, guys. C is the correct answer. Tell me. Do not try to solve this portion, my dear friends, in your examination. If you're solving again this one, then definitely you are wasting your time, because the value will remain same, only the data will change, like this one is A, this one is B, and this one is F1, this one is F2, nothing else, right? But the value will remain same, just you have to replace that and add that, my dear friends. After that you are able to get the value of F over here. Why we are considering F1 and F2? Because, my dear friends, we are not able to analyze this particular structure by considering whole structure at one time. Why it is so? Because the complete structure is indeterminate at the single time. If you separate this particular portion as well as this portion, you are able to analyze this one, because it will become determinate as well as this one become determinate. That's why. Swamijit, we are writing summation moment at A is equal to 0, not moment at A is equal to 0. Listen carefully. We are writing summation moment at A is equal to 0, and it is always applicable in any structure, my dear friends. This is nothing else. This is your static equilibrium equation. This is our static equilibrium equation, guys. Right? Okay. So, my dear friends, this is all about for today. This is all about for today. If you have any doubt, any query, then let me know. I'm still here to solve your query and solve your doubt. Okay? Tell me, guys. So those who are new, my dear friends, listen carefully. Those who are new, just write your comment, write your doubt, my dear friends, in the comment box, and listen carefully. Those who are new, you can join my session on 2 p.m. on Gradeup Civil Champion channel. And in that particular channel, I'm just taking the session in Hindi, my dear friends. If you know Hindi language, then you are able to join that particular series. Okay. And my dear friends, if you want to join my further sessions like free classes, then you can join me on Gradeup app at 6 p.m. daily. Okay. So just come, my dear friends, at 6 p.m. on Gradeup app. If you want to follow me, my dear friends, you can follow me. The link is given below in the description box, my dear friends. Just you have to click it, and definitely you are able to follow me, as well as you will get the session which is running at the 6 p.m. And these sessions are very, very important for your GATE examination, because I am designing the problem over there, my dear friends, for your structure analysis and RCC. And definitely a lot of students get benefit from these type of session. Okay. Sir, what happen if no hinge is there? Then we are not able to analyze this particular structure directly, right? If this hinge is not there, then we are not able to analyze this particular structure directly. Okay. Understood? Okay, guys. Okay. So, any other doubt, any other query from your side, guys? Then let me know. Okay, guys. So those who are new, just listen carefully, my dear friends. You can join our Gradeup Super also, in which you will get the different courses like Gear Up, Rank Up, and Vision 2022 course. If you want to join, if you want to learn in detail, my dear friends, you can contact on this particular number, right? And these are our staff faculties who will teach on Gradeup, my dear friends, right? And these are Gradeup achievers, right? These are Gradeup achievers, my dear friends. And my dear friends, after 10th of December, the cost will be increased. So if you want to join early, you can join our platform, my dear friends. Okay. And my dear friends, you will get definitely India best faculty team over here, complete doubt resolution, full syllabus coverage, as well as you will get the green card, right? In green card, you will get the access of online mock test, which is designed by Topper based on latest pattern of examination. And my dear friends, definitely you will get unlimited access to all the structure life courses as well as mock test. Okay. So this is all about for today. Hope you enjoyed this particular session. आपने काफी कुछ सीखा होगा, काफी कुछ learn करा होगा बच्चों. And definitely I will try to put these type of session, my dear friends, for you guys. Okay. So again, we will meet tomorrow at the same timing on the same channel at 7 p.m. So my dear friends, go Gradeup.